Hello everyone, this video is continuation to lesson number 3. In this part of the lesson we'll talk about conversions that require more than one step, and we'll start first by learning about conversion within the area units and within the volume units. Let's try to understand how units of length is different from unit of areas. Let me start giving you an example from something we are all familiar with. You know that 1 foot is equal to how many inches? We all know that 1 foot is equivalent to 12 inches. Now what does that mean? This means that if you have 1 foot length and compare it to 1 inch length, so this is 1 foot and this is 1 inch. Suppose this line is 1 foot long and this line is 1 inch long. 1 foot equal to 12 inches means you need 12 of those inch length to make up 1 foot length. Okay, that's the meaning of 1 foot equal to 12 inches. Now if you compare that to unit of area, how many inch square are there in 1 square foot? If you have one, in that case you have to draw a square rather than a line. So this is the square where each side is 1 foot long. Now a 1 inch square will be a square that each side is 1 inch long. Now the question is, how many of those square inches will fill in the square foot square? Is it 12? As the case with the length. Now we know actually if you try to place 12 of those square inches, they'll make up 1 column here. Okay, so actually what you need 12 by 12 to fill in the square foot square. So 1 foot square will be equal to 12 times 12. So 1 square foot will be equal to 144 square inches. Okay, so note here that although 1 foot is equal to 12 inches, that does not mean that square foot will be equal to 12 square inches. Actually, you have to square the number the same way we square the units. So here 1 will be squared, become 1. Foot will be squared, will become square foot. 12 has to be squared, which will become 144. And inch, when you square it, is square inch. The same thing applied on volume. In the case of volume, you have to cube the numbers the same way you cube the units. So here in this example, we are asked to convert 67 cubic meters to cubic centimeter. The prefix centi means 100, which is 10 to the negative 2. 1 over 100, which is 10 to the negative 2. So 1 centimeter will be 100th of a meter. Now to convert it to unit of volume, we have to cube everything. The numbers and the units has to be cubed. So 1 cube will become 1. Centimeter cube will become cubic centimeter. 10 to the negative 2 cube will become 10 to the negative 6. Let me remind you here with math, when you have 10 to the power x and you raise it to the power y, you'll be basically multiplying x by y, which will give you 10 to the power x times y. So 10 to the negative 2 raised to the power 3 will be 3 times 10 to the negative 2, which will change the power to negative 6. And now if you want to follow the dimensional analysis method, you multiply 67 cubic meter by the conversion factor that has centimeter in the numerator and cubic meter in the denominator, so that cubic meter will cancel out and you'll get the answer in cubic centimeter. And 67 divided by 10 to the negative 6 will give you 6.7 times 10 to the power 7, because 1 over 10 to the negative 6 is 10 to the positive 6. When you take the reciprocal, the inverse of 10 to the power x, or 10 in that case 10 to the power negative x, the answer will be 10 to the positive x. The sign will flip. Okay, now let's see an example here of similar problem. Question number 5 in the discussion exercises tells you that you want to install carpet in your house and you have a specific brand in your mind. You found this brand in 2 stores, so you're trying to figure out which one is a better deal, $1.5 per square foot or $9 per square yard. So you're trying to decide which one is bigger. Of course, the one that is less will be the better deal. If 9, now of course 1.5 and 9, we know that 9 is bigger than 1.5, but we are not looking at the numbers only, we are looking at the units. So what we need to do here, we need to convert one of them to the other. So for example, if we converted $9 per square yard to $1 per square foot and we got an answer that is less than 1.5, then that means $9 per square yard is less than $1.5 per square foot. While if we got bigger than 1.5, then this means that the $9 per square yard is bigger than $1.5 per square foot. And that's what will determine our decision, which is the better deal. So let's go ahead and convert $9 per square yard and see what will be its equivalence in dollar per square foot. Now, as you see in this conversion, and this is the map, we are trying to change the denominator, not the numerator as we did before. We are trying to change the denominator from square yard to square foot while keeping the numerator the same, because the unit here is still dollar, so we don't want to mess with the numerator. Now, to set it in a way that will convert the denominator from square yard to square foot, we have to start first by deciding the conversion statement that relates square yard to square foot. Now, we know that 1 yard is equivalent to 3 feet. And we know also that the relation between square yard and square foot is not the same as the relation between yard and foot. To convert the relation to unit of area, we have to square the units and the numbers. So if you square 1 here, it will give you 1. When you square yard, it will give you square yard. So that's yard square. This is equal to. And now square the 3, this will give you 9. And when you square foot, this will give you square foot. So square yard is equivalent to 9 square foot. So now we have the conversion statement that will enable us to write the conversion factor to convert $9 per square yard to $1 per square foot. So if we go ahead and carry out the calculation, we are starting with $9 per square yard, and we need to multiply it by the conversion factor that will cancel out square yard and give us the answer per square foot. So square yard has to be in the numerator of that conversion factor, while square foot has to be in the denominator. Again, here notice that we place the unit we want to convert to in the denominator instead of the numerator, because here we are changing the denominator from square yard to square foot. And we can go ahead and plug the numbers. So we'll place 1 beside square yard, and we'll place 9 beside square foot. Remember, the numbers in the conversion factor come from the numbers in the conversion statement. So as you see here, square yard will cancel out with square yard, and you'll have $9 times 1 over 9 square foot, and this will yield 1, because 9 will cancel out with 9, and you get $1. We have dollar here per square foot divided by square foot. So notice here what we were able to find is that $9 per square yard is equivalent to $1 per square foot. So which one is a better deal? Now, since $9 per square yard is equivalent to $1 per square foot, and since $1 per square foot is less than $1.5 per square foot, therefore $9 per square yard is a better deal. So actually $9 per square yard is less than $1.5 per square foot. Yes, actually 9 here is less than 1.5 because the units, which is dollar per square yard, is far less than the unit, which is dollar per foot. So this is the better deal. Alright, so that's regarding to conversion within the area units and volume units. Now let's look at problems that require multiple conversions. This is the dimension of an Olympic swimming pool. It's 164 feet long, 82 feet width, and 6.56 feet depth. So this constitutes the volume of this swimming pool, and this constitutes also the volume of the water that you place in this swimming pool. This volume is around 88,263 cubic foot. So this is the amount of water you need to place in this swimming pool to fill it up to that depth of 6.56 feet. The question is, how many gallons of water are required to fill up this pool? So how many gallons of water will fill up this volume of 88,263 cubic foot? So the problem here is to convert from cubic foot to gallons, and both of those are unit of volume. What is missing in this question is a direct relation between cubic foot and gallons. We don't have conversion statement that relate cubic foot to gallons. Instead, we have relation between cubic meter and cubic foot, and also we have relation between cubic meter and gallons. So cubic meter is the link between cubic foot and gallons, so we have to use it as an intermediate unit that will enable us to go from cubic foot to gallons. So we have to go through two conversions here. First, we'll convert the cubic foot to cubic meter. Then after that, we'll convert the cubic meter to gallons. This is the math. Step number 2, where you place the units in the conversion factors. So since we are going from cubic foot to cubic meter in the first conversion, we have to place the cubic foot in the denominator so that cubic foot will cancel out, and we have to place cubic meter in the numerator so that we get the answer in cubic meter. So this step here will convert cubic foot to cubic meter. Then in the next step, we have to cancel out cubic meter and get the answer in gallons. So we'll place cubic meter in the denominator, and we'll place gallons in the numerator so that now cubic meter will cancel out with cubic meter and we'll get the answer in gallons. Now step number 3, we'll plug the numbers. Since 1 cubic meter is 35.3 cubic foot, so we'll place 1 beside cubic meter and we'll place 35.3 beside cubic foot. And on the next one, 1 cubic meter is equivalent to 264 gallons. So 264 go beside gallons, 1 goes beside cubic meter. And now we'll carry out the calculation. Again, notice here the units will cancel out nicely so that we are left with gallons only. And if you carry out the calculation, this will yield around 660,000 gallons. So that's the amount of water required to fill up an Olympic swimming pool. 660,000 gallons of water, this is equivalent to around 2,750 tons of water, just to give you a perspective how much water is required. Question number 6 in the discussion. We are back to the grocery store and we are told that tomatoes are sold for $1.28 per pound, while cherry is sold for $2.65 per pound. Now the question is, 3 pounds of cherry is equivalent to how many pounds of tomato? Meaning, with the price of 3 pounds of cherry, how many pounds of tomato can you buy? Here we are asked to convert 3 pounds of cherry to pounds of tomatoes. Now as you see here, we don't have direct relation between pounds of cherry and pounds of tomato, but we have an intermediate unit, dollar. Dollar is related to both. $1.28 is equivalent to 1 pound of tomatoes and $2.65 is equivalent to 1 pound of cherry. So we have those conversion statements. 1 pound of tomatoes is equivalent to $1.28 and 1 pound of cherry is equivalent to $2.65. So dollar here is the intermediate unit. So now to do the conversion, we have to go through an intermediate step. We have to convert the 3 pounds of cherry to dollars, and then after that we have to convert the dollars to pounds of tomatoes. Okay, so go ahead and set the equation. So it's 3 pounds of cherry times the conversion factor that will change pounds of cherry to dollars. So we have to have pounds of cherry in the denominator and the dollar in the numerator, times the conversion factor that will cancel out dollars and give us the answer in pounds of tomatoes. In the second step, this is the first step here, this is the second, where you need to convert the dollar to pounds of tomatoes. So you need to cancel out dollars, therefore dollars has to be in the denominator and pounds of tomatoes has to be in the numerator. And now we can go ahead and plug the numbers that come from where? The numbers come from the conversion statements. So 1 pound of cherry is equivalent to $2.65, so 2.65 here beside dollar. And then pounds of tomatoes and dollar here, 1 pound of tomato, so place 1 pound of tomato here, is equivalent to $1.28. So now if you look at the units, pounds of cherry will cancel out with pounds of cherry here, and dollar will cancel out with dollar, and you'll be left with pounds of tomatoes. And for the numbers, you have 3 times 2.65 times 1 divided by 1.28. Okay, part D of lesson number 3 is about density. And density is defined as the measure of compactness. How dense something is, has to do with how much mass you have per volume. So density is equal mass over volume, meaning the bigger the mass, the bigger the density, and the bigger the volume, the less the density. Notice here volume is in the denominator, meaning if the volume is big, density is less. Because remember, density is about compactness. So you need a smaller volume to get bigger density. Now, the special thing about density is a fingerprint. Each material has its unique value of density. Whether iron, zinc, water, alcohol, air, every object has its unique value of density, and this density value is the same no matter how much volume you have of this material. So 1000 gram of iron has the same density as 1 gram of iron. Now let's try to explore the meaning of density more here. Water has density of 1 gram per cubic centimeter, while mercury has density of 13.6 gram per cubic centimeter. What does that mean? This simply means if you have 1 cubic centimeter of water, suppose this is 1 cubic centimeter of water, and then here you have 1 cubic centimeter of mercury, and this is 1 cubic centimeter of water. The mass of 1 cubic centimeter of mercury will be how much? Will be 13.6 grams. while the mass of 1 cubic centimeter of water will be how much? Will be 1 gram. 1 gram. So the same volume of mercury will be 13.6 times more heavy than the same volume of water. Notice here the key word is the same volume. So this is per cubic centimeter. So this is what density tells us. Tells us how much mass you have per volume, per unit volume. And notice here that the density will change when you change the units. So density of water is 1 gram per cubic centimeter, but if you convert the gram per cubic centimeter to kilogram per cubic meter, the value of the density will change. It will become 1000. So this is 1000 kilogram per cubic meter, which means that if you have 1 cubic meter of water is 1000 kilogram. Now in this question here, it asks you to find the mass of water in a bathtub whose interior is 1.5 meter long, 0.7 meter wide, and is filled to a height of 0.5 meters. So we're asked to find the volume and we are given the density. And this is a very important question. I asked similar questions in the test. So to rearrange the equation in order to solve for the mass, we have to multiply both sides of the equation by the conjugate of V. And the conjugate of 1 over V is V. So we have to multiply both sides of the equation by V. And this will yield mass equal to density times volume. Okay. Just here a side note, when you have, for example, Z equal x over y, you can solve for x by multiplying z by y, and also you can solve for y. If you need to find y in terms of x and z, y will be equal to what? Y will be equal to x over z. Okay, so also if you want to find the volume out of density and mass, volume will be mass over density. So now to solve for the mass, we have to multiply the density by the volume. Here the volume is not given directly, but we are given the dimensions of that bathtub that has the water in it. Of course, liquids always take the shape and therefore the volume of whatever container you place them in. So the volume of the bathtub and therefore the volume of the water will be the length times the width times the height, which will yield 0.53 cubic meter. So this will be the volume of the water in this bathtub. And the mass will be density times volume. So it's 1000 kilogram per cubic meter times 0.53. Notice here cubic meter will cancel out and you will get the answer in kilograms. Just to give you a perspective here, the mass of the water came out to be 530 kilograms. This is equivalent to 2200 pounds. This will be the amount of water or the weight of that water in this bathtub. And this is important actually. This is one of the important application of density. You don't have to weigh the water in this bathtub in order to figure out its mass. All what you need to do is to know the volume, and we know the density of the water, so mass will be simply density times volume. Okay, in question number 7 in the discussion exercise number 3, we are asked to find the mass in kilogram and gram, and you are given the dimension of that rectangular container that has water in it. And we are given the density of water. Notice here the density is given in gram per cubic centimeter, not kilogram per cubic meter. So it's only 1. And you don't have to memorize those values. Those will be given to you in the test. So to solve for the mass, we know mass is density times volume. Since density is mass over volume, mass will be density times volume. And in order to find the volume, we have to multiply the 3 dimensions. I'm just going over the main guidelines here to help you start on this problem. So volume will be the 3 dimensions multiplied by each other, and this will give you the answer in cubic centimeter. And now to find the mass, you have to multiply the density, which will be 1 gram per cubic centimeter. This is the density, times the volume, which will be whatever the answer here in cubic centimeter. So you can see here cubic centimeter will cancel out and you get the answer in grams. And then to convert the answer from grams to kilograms, because you're asked here to find the mass in both kilograms and grams. So going from grams to kilograms is going from small unit to big unit. So you are increasing the units. So the number has to decrease. And since kilo is 1000, which is 10 to the power 3, this means that we have to move the decimal point to the left 3 places by 1000. So here the number will decrease since the unit is increasing. So keep that in mind when you solve this problem. Okay, question number 8. Assume that the authority has finally reached a decision to change all the British system units into metric units. And suppose your task as a physical science expert is to convert 60 miles per hour sign into kilometer per hour sign. How can you do this conversion? So again, the problem here is to convert 60, and this is mile per hour, to kilometer per hour. And notice here you're asked to find it, so you have 1 and 0 digit. Speed limits are not fractions, and usually they end with 0 or 5, like 85, 65, 70, 80, 90. You don't see 62 miles per hour or 63.5 miles per hour. It always ends with either 0 or 5, and it does not have fractions. In this conversion, we are keeping the denominator as it is, so we're not messing with the denominator. It's hour in the left hand side, also hour has on the right hand side. We are changing only the numerator from miles to kilometer. Now if you look at the inside of the back cover of your textbook, you'll see that you have several conversions, and one of them is the relation between mile and kilometer. 1 mile is equivalent to 1.609 kilometer. So now if you do the conversion, you are multiplying 60 miles per hour by the conversion factor that will cancel out mile, so mile has to be in the denominator, and give you the answer in kilometer per hour. So kilometer has to be in the numerator, and you can see here from the units, mile should cancel out, and you'll get the answer in kilometer per hour. Now for the numbers, place 1.609 beside kilometer, and you'll place 1 beside mile. So you're multiplying 60 by 1.609. So I'll let you do the calculation here and make sure to round off the answer so that you have 1 and 0 digit in your final answer. This will conclude lesson number 3. I hope you found those 2 videos over lesson number 3 educational. Thank you.